Tēnā koutou katoa. Welcome back to a brand new math video. Today we are going to prove that the limit as x tends to infinity of e to the x multiplied by sine of x divided by x squared plus 1 is indeed infinity. In other words, it diverges. And straight away you notice, well, we have alternating something here. The sine function. That is an alternating sequence of some sort because it ranges from the positive real numbers to the negative real numbers forever. So for example, if we were to look at the function sine of x by itself, we get this forever. We get that wavy function. So as we tend to infinity, there's no true limit. So right away we know that, well, that points out that this limit must diverge. But we can use some common sense here to show that it also diverges without using that geometric interpretation of the sine function. So let's go ahead and let's do the limit. So L is equal to the limit as x tends to infinity. Basically the same thing. E to the x sine of x all divided by x squared plus 1. We know that the exponential function increases very, very fast. So we sort of get an idea that yes, it is going to diverge. But let's plug in our values first. Here we get e to the infinity of sine of infinity, which in itself does not have a value, as I just said, over infinity plus 1. Infinity squared plus 1. What is bigger, e to the infinity or an infinity squared? Obviously, e to the infinity is going to be exponentially much more faster growing towards infinity. But both are infinity, so what can we do here? Well, we get infinity over infinity. We can apply L'Hopital's rule again, just like the last video that we did on the limit. So we take the derivatives of both the bottom and the top, the numerator and the denominator, and we pop them in our limit. So evaluating the derivative of the numerator, we get our top numerator back, but because we have to apply the product rule, we also get e to the x cosine x. And here we get 2x. Okay, well that is going to go to infinity over infinity again. Well, that's annoying. We have to apply L'Hopital's rule again. Can we do this? The answer is yes. I will prove that in another video if you are interested in the proof. I will link that video down below. So let's go ahead and, oh my god, the keyboard came up. Interesting. So let's go ahead and evaluate the derivatives. We get L is equal to the limit as x tends to infinity of the derivative of this. So we get e to the x sine of x again, plus the e to the x of cosine of x. And then we take the derivative of that, we get plus e to the x cosine of x. Hey, nice. Nice. We can combine those two, can't we? And then we get minus, yes, minus e to the x sine of x. And that's all going to be divisible by 2. And what you notice there is there's a bit of simplification that we can do. We can get rid of these here. And finally, we get the limit as x tends to infinity of 2 multiplied by e to the x cosine of x divided by 2. So we get the limit as x tends to infinity of e to the x cosine of x. Okay. We still have an alternating function here. Again, just like the sine function, it alternates between the positives and a negative, real numbers between 1 and -1. But we have an exponentially growing function here also. So we get the limit. So we get L is equal to the limit as x tends to infinity, which is e to the infinity of cosine infinity. We know that we have no absolute value for cosine infinity at all. But what we can say is, well, e to the infinity is going to diverge to infinity. So therefore, our reasoning is that we get that the function diverges to infinity. And that's how we can prove, using L'Hopital's rule. We also can use some geometric explanations, as I pointed out earlier. We proved that indeed this limit diverges. So guys, I hope you guys enjoyed this video. I'm making a few more math videos in my spare time. I enjoy doing them. I'm going to get a whiteboard and hopefully use that. That won't be for a while though, but I feel like this, using the surface thing, I have less interaction with an audience. And, you know, I know I don't have many subscribers. I don't have much of a following. There's something about writing on a whiteboard, improving stuff on a whiteboard in front of a camera that I just enjoy. So guys, leave a like if you liked this video, and I'll see you guys in the next one.